Greetings panel. This is Jayesh Purohit from EC5.
Greetings panel, this is Manik Gupta from EC5.
Greetings panel, this is Mansi Nagpal from batch EC5.
Greetings panel, this is Purva from EC4.
And we students of Group 11 will be presenting you to our Capstone project based on breast cancer detection using machine learning and deep learning models. So starting with the project, what we are first doing is importing the libraries necessary for this project. Starting with TensorFlow, then the image data generator, and all the way to the matplotlib.image. Moving on, what we have used is as a novelty for this project is the Wiener filter. What Wiener filter does is for a particular image, it removes the noise and amplifies some important areas for a particular image. For example, in this project, in what we have used is a cellular image of a breast cancer. So what if we have a blur cellular image of a cancer? What it does, it removes the noise and amplifies the area of the cell, due to which the recognition pattern for the machine learning model becomes easier and the accuracy gets boosted. So this is the implementation of the Wiener filter, in which we have used the Convolve 2D model and thus have used the Wiener filter. Now, moving on, we have used the train data generator and the training set. What we are doing over here is take the data set from our libraries and applying image augmentation to this. What is image augmentation? In image augmentation, what do? Is take an image and apply some basic functions on it. For example, flipping the image, zooming the image, and share range of the image, and rescaling the image also, as we can see in these parameters over here. So we are applied this augmentation. What it does, it increases the variety of the image that we have. So here we can see it has found 658 images belonging to two classes, and multiplied by 4, we can see we are having around 2500 images. Similarly, what we have done is we taking the images from the test data set, which is the validation data set, but here we have not applied the augmentation because we do not need to augment the testing set. Now, first model that we will be implementing over here is the VGG16 model. The VGG16 model is a 16 layer model, and it is very loss depreciating model, which is very popular in these days. So here what we are doing is importing the VGG16 model, and the optimizer, for the optimizer we have used the RMS prop optimizer. So here we can see the input shape of the image is 224 by 224, and 3 denotes the colored image. If we have the parameter over here was 1, the image would have been a black and white image. We have set the weights, which is by default the ImageNet of the VGG16 models, and here we are applying the layers. Here we are setting the dropout rate and then adding the density. Here we are initializing the model. Here we are compiling the model with the RMS prop optimizer, setting the loss rate is equal to 10 to the power minus 4. The loss is binary cross entropy. Here binary cross entropy means that we are categorizing into only two, that is benign and malignant. If it was categorical cross entropy, we would have been classifying into various categories. And the matrix that we are here assuming is accuracy, which will show the accuracy of the model. So here we have fitted, that is trained the model. So here we can see the model has been going over 18 steps per epoch, and we are going for over 12 epochs. So starting with epoch number 1, the accuracy was of mere 53%, and the time it is taking per epoch is 260 seconds. And the accuracy after 12 epochs finally was reached to the 90%, and the validation accuracy was reached to 95%. So here what we are doing is plotting the training and validation accuracy with the help of loss and validation loss. Here we can see that the loss that we have initially was around 1, but as the epochs increase, we can see the loss of the model has decreased very much. Here I have saved the model file for the deployment purposes. Moving on, we have the Inception V3 model. Inception V3 is a convolutional neural network for assisting in image analysis and object detection, and got its start as a module for GoogleNet. It is the third edition of Google's Inception convolutional neural network, originally introduced during the ImageNet recognition challenge. Here, as you can see, similarly, we have resized the image for 150 to 150 because the input image for this model is different from the VGG16 models. Here we have first setting the layers, the trainable layers as false, flattening the layer, then adding the dense layer, and then the dropout layer. And then we are then initializing the model and then compiling the model. Yeah. So now for the deployment side, what we have used is Flask for the deployment purposes. Here we have defined two files, index.html, predate.html. Index is the front end page that we first encounter when we are visiting the model, and then the predicted HTML is when we have submitted the image and the prediction has been done. The app.py is the Python file which would be working for the backend and the model purposes. The model that we first used, the four models, are then loaded in the app.py, and then they are worked in the ensemble model. What is ensemble learning? What we are doing over here is using four machine learning models, and then the output of these four models are used in cohesion with each other, due to which the accuracy of all the four models is increased very much, because we are using the average of the all the models output. For example, if three models are predicting that the given image is cancelled, but the first is, if the last model is predicting that the image is not is cancelled, so what we are doing is a majority that the model is cancelled, due to which there is large number of predictions which are done right, which are not done by various models, due to which the overall accuracy has been boosted very much. So this is the main novelty of our project. So here is the index HTML, predicted HTML, and the app.py. So this is the code for the deployment, and here is the final basic deployment model. This is the cancer prediction, very basic front end for the user. We choose file from here. This is the model that we have here. As you can see, we are dealing with blind images right now, so I will upload a blind images and check if it is predicting it correct. It is running. As you can see, it is correctly predicted that we have done an benign images. So here is the image that we uploaded, and it is the associate probability over here. As you can clearly see that using four models, it was a very fast prediction from the model's end, and very simple user interface model for a patient that has a scan for breast cancer. Thank you very much. And this was all the model. Thank you.